Hello students, welcome to data structure course. Today we are going to study double-ended queue. In my previous video, we study the problems or limitations of linear queue, where we saw the problem is we can insert through rear end only, and one more problem is we can delete through front end only. To overcome that problem, we are going to see the double-ended queue. Double-ended queue. In this queue, or also we can call it DQ. DQ. It is a short form of double-ended queue. Double-ended queue is a data structure, also called hill-tail linked list, for which element can be added or deleted from the front or rear end also. Okay, where in double-ended queue we can perform insertion and deletion from the both end. We can insert and delete through the both end. So this is called double-ended queue. Okay, so basically double-ended queue having two variations. The first one is a input restricted DQ. Input restricted DQ, and second one is the output restricted DQ. Okay, so let's see one by one. In an input restricted DQ is one where deletion can be made from both end, but input only made at only one end. Okay, what is input restricted DQ? An input restricted DQ is one where deletion can be made from both end. Okay, deletion can be made from both end, but input can only be made at one end. So basically here we are restricting only input. We can make deletion from both end. Both end means from we can delete element from the front end also and rear end also. So let's see diagrammatically. So this is what your array. Okay, so here we can make deletion through front end also. We can make deletion through front end also. Okay, in linear queue we can delete element to front end and also rear end also. So this is what your rear end. Now we can deletion through rear end and also insertion through rear end. So what is input restricted? Where input are restricted means we can perform insertion through rear end only, but we can perform deletion through both end. Both end means through in rear end and front end also. Okay, so this is what input restricted double-ended queue. Very simple. Similarly, in output restricted double-ended queue, in output restricted double-ended queue, what will going to happen? We can perform insertion through both end, like from front end and rear end. We can perform insertion through both end. Okay, and deletion through only front end. We can perform insertion to both end, that is front end and rear end, but deletion can be only front end. Like example, suppose this is what your front and this is what your rear. So we can perform insertion from both end. So this is front end and we can inserting through front end. So insert, this is what deletion, and also we can insert to rear end also. So this is what output restricted double-ended queue. Okay. Now let's see the algorithm for all these operation. Means here we are going to see algorithm for insertion through rear end, insertion through front end, then deletion through rear end and deletion through front end also. Okay, so let's see the first algorithm, which is add through. Actually we already learned this DQ rear end. Okay, add in a DQ through rear end. So it will take atom as a input, DQ, which is array, in which we are going to insert the size of that array and rear position. Okay, so first statement is if rear is equal to n is size of array, then call DQ is full. Very simple. If rear is maximum reach to the maximum size of array, so that means rear is Q is full. If it is not, else rear is equal to rear plus 1. We are going to increment that rear by 1, and in DQ we are going to insert that atom at rear position. So this is like a linear queue. This algorithm is like linear queue, very simple, since we are inserting through rear end only. So end of add in DQ through rear end, okay. So this is very simple, where we are going to insert through rear end. We simply check whether our rear reach to the maximum size. If it is, then we will say DQ is full, else we are going to increment rear by 1 position, and at that position we are going to insert an atom. Okay, now we are going to see the algorithm for add through front end. Add through, add and deque through front end. Okay, so this algorithm basically takes input as a item. It takes as a item array, that is deque, the size of array, and front position. Okay, now here we are going to add through front. So we can add whenever our front is not pointing to 0th position, means it is pointing to 1 2 3, either any index. If it is at index 0, then we are going to say deque is full. Okay, like this. If your front is equal to 0, then call deque is full. Okay, we are inserting through front end. Okay, else deque of front position. Okay, else deque of front position is equal to atom, and then we are going to decrement that front by front is equal to front minus 1. Sorry, I must not use semicolon here since it is algorithm. Okay, so this is step number 3, and end of add deque through front end. Now what is the logic behind this? Suppose how it will work. This is what your array of having size 4 elements. Now you have element here B, C, D. Your rear reach to the maximum site, sorry, 0, 1, index location, and your front is pointing to here, means this element is also deleted. Okay, means we have two vacant place. Now suppose if you call this add to front end. Okay, so if check if front is equal to 0, then call deque is empty. Now my front is pointing to index location 1. Okay, and now else deque of front is equal to atom, else deque of front is equal to atom. So whenever where front is pointing, at that location we simply going to put an element. So suppose I put here element E. Okay, and then front is equal to front minus 1. So your front will going to point here. Now we supposed to update over this condition, that is if you are using array, so if front is less than 0, if front is less than 0, then call deque is empty. Since if it is pointing to 0, if we keep this condition, if front is equal to 0, then it will say q is full. Okay, so we cannot utilize this place. That is why I am changing this condition. But in algorithm we simply use front is equal to 0. Okay, but in implementation we are going to use if front is less than 0, then call deque is full. So we can efficiently utilize this space also. And one more thing, we can insert through front and rear end both. Okay, so this is what adding to front end. Now let's see deleting through rear end. So delete dq through rear end only. Okay, this will take input as a atom dq, which is array size, and both front and rear position, front and rear position. Okay, now whenever we are going to delete through rear end, we need to check if front is equal to rear. But obviously, if front is equal to rear, our default condition for empty is what? If front and rear both are pointing to same position, that is means q is empty. That is means q is empty. So that is why we are using same condition here. If front and rear both are pointing to same position, then call dq is empty, and if it is empty, we cannot delete element through rear end. Okay, now second, else if it is not empty, so what we are going to do, we are going to decrement our rear position. Okay, we are decrement our rear position by 1. Okay, we are going to decrement our rear position by 1. So that is means we are remove that rear is equal to rear minus 1. Okay, rear is equal to rear minus 1, and we are collecting that element into this atom variable for future purpose, like for display the element. So the key of okay, what we are going to do, we are going to write this condition first. Okay, sorry for this. Atom is equal to dq of rear, and here rear is equal to rear minus 1. Okay, rear is equal to rear minus 1, and this is what end of dq, sorry, delete dq through rear end, Okay, so very simple. If your front and rear both are pointing to same positions, means what? Q is empty, we cannot delete through rear end. Okay, and if it is not pointing to same positions, means what? We can delete through rear end. So we simply decrement our rear by 1 position. Okay, very simple logic. Okay, likewise the same we are going to do in delete through front end also. So how we are going to delete? As usual, we use this same logic in linear queue also. So delete dq through front end. Again, it is take input as a your atom. Atom is a variable which collects input, which collects basically the element which we are going to delete, then front, and then rear variable. Okay, now if simple logic, again same, front is equal to rear, it will say, then call dq is empty, else what we are going to do, in the atom variable, we are going to collect that atom which is in a DQ at front position. Okay, and then simply say front is equal to front minus 1. Okay, and the last line is what? End of delete DQ from front end. So this is what the algorithm for double-ended queue. Okay, thank you very much.